Now that you have already seen what CsensorNet is all about, let's take a deep dive and understand its basic building blocks. In this video, I will primarily focus on explaining to you the CsensorNet architecture, its various components, and exactly how they integrate with each other. CsensorNet can primarily be divided into the following components. 1. Sensors and devices. 2. Gateway and device hub. 3. Node-RED. 4. Message broker and queue. 5. NoSQL databases. And 6. Visualization/UI. Now, let me explain each of these in detail. We'll start with sensor and device components. CsensorNet supports a multitude of sensors. We have DHT11, which does temperature and humidity sensing, ultrasonic sensors, which does distance, and proximity sensors. And these are just some of the different devices that work with CsensorNet very effectively. Now we come to the point where we need to get the data from the sensors. Every sensor transmits data through an industry standardized mechanism, often referred to as a protocol. CsensorNet supports a variety of protocols which govern the communication and data exchange for the sensors. Protocol like TCP, RFID, BLE, or Bluetooth are supported by CsensorNet already. In the future, we are also planning to support protocols like LoRa, which is also known as a long-range band. This would enable us to communicate with devices which are at very large distances. Gateway or device hub. This acts as a central point connecting various devices and sensors. Device hub enables devices to send data further down the line. We are currently using a Raspberry Pi as our device hub. The Raspberry Pi is a credit card-sized computer that costs between $5 and $35. It is available anywhere in the world and can function as a proper desktop computer or be used to build smart devices. The next component, also known as Node-RED, is perhaps the heart of CsensorNet. Node-RED is IBM's open source IoT product. It resides on the gateway and comes as part of the Raspbian OS. Node-RED enables CsensorNet to enrich or transmit data as is through the easy-to-create workflows. Its primary purpose is to stitch together the web service and hardware by replacing the low-level coding tasks. It also has a very lightweight runtime environment. Event-driven and non-blocking models, local or cloud deployments, simple mechanisms to import or export workflows as JSON make it ideal for IoT. It is at this point we have actually captured the data from the devices. However, we still lack the mechanism to send the data to the backend where we can actually derive some meaning out of it. CsensorNet's message broker/queue component is the solution to this issue. It works on the publish-subscribe, also known as pub-sub principle. In simple terms, it means that it's getting the data from someone who produces it and giving the data to someone who needs it. It is a messaging system which is capable of handling very high volumes of data. The feature which makes it the obvious choice for IoT are 1. Scalability. So it provides a 4-dimensional scalability like event producer, processor, consumer, and connector scalability. In the most simplistic terms, it scales without downtime. And then we move to fault tolerance. It can easily handle failures without any data loss or downtime. And then last is performance. It supports high throughput of publishing and subscribing messages. For this solution to work, there needs to be someone at the other end of the message broker/queue who would be storing the data. Cassandra is the obvious choice for this. It is a NoSQL, distributed, decentralized, and open source data storage system. It can handle large amounts of unstructured data. It is open source, supports elastic scalability, and has high performance. Cassandra can easily be scaled up or scaled down without disturbing the cluster, which effectively means zero downtime. It supports replication, which translates into a guaranteed response. So, if one node fails, the other takes over. Now, all this data that we have captured would not make any sense unless we derive an actionable and meaningful conclusion from it. So the question is, how do we do that? Visualization and analytics are the answer. Visualization components of CsensorNet help in the giving of an in-depth insight to this data. Whether you want to see the data as a pie chart, line chart, bar graph, or you intend to export your data to a third-party system or your downstream systems, the choice is yours. Visualization components give you the option to monitor live data or do historical data later. Since we've covered all the main components, I think it's the right time to practically see how all of these pieces come together and create what we know as CsensorNet. We have lined up a few demos for you. Enjoy!